Observe this image. It's a remarkable photo captured by a $10 billion marvel of engineering, the James Webb Space Telescope, stationed 1.5 million kilometers from Earth. Scientists across the globe waited nearly 25 years to witness this view. At first glance, it may seem like just another image of space, but its significance rivals historic moments like humanity's first steps on the moon or Yuri Gagarin's inaugural journey beyond our atmosphere. So, what does this photo truly reveal? It shows a star nestled within our Milky Way galaxy, marking the James Webb Telescope's first successful capture after deployment. This confirms not only the full functionality of the telescope, but also its outstanding performance, surpassing all expectations. This photo represents a monumental leap, positioning humanity on the edge of new cosmic discoveries. With the Webb's capabilities designed to detect life-supporting conditions beyond Earth, it brings us closer than ever to answering the question, are we alone in the universe? Constructing the James Webb Telescope involved 25 years of work by thousands of engineers and scientists worldwide, with a $10 billion investment. But what do scientists hope to achieve with it? Consider the construction of the 27-kilometer Large Hadron Collider, completed over a decade with a similar budget, which led to the discovery of the Higgs boson. Online, you'll find countless articles and videos about this space telescope, perhaps already familiar with its infrared capabilities and sensitivity, 100 times that of the Hubble. Creating this precision required an intricate folding mirror of 18 hexagonal segments. Webb was launched on December 25, 2021, from the Kourou spaceport in French Guiana. As the Ariane 5 rocket disappeared into the clouds, thousands around the world held their breath, hoping for success. But the mission's suspense continued long after launch. This three-story telescope, with a surface area comparable to a 25-car parking lot, had to be deployed and made operational in space without human intervention. The telescope's success hinged not only on unfolding its sunshield and mirror, but also on aligning the 18 segments with nanometer precision, a tremendously complex task. In February, encouraging news arrived as the telescope systems successfully reached full operation. Shortly after, the first photograph, showing the star HD 84406 in the Ursa Major constellation, captivated the world. This star, selected to test the telescope's performance, sparked intense global interest despite its simplicity. Its isolation in the sky made it ideal for confirming James Webb Telescope's functionality, enabling precise calibration of each mirror segment. To ensure the near-infrared camera could capture and focus light, scientists spent nearly 25 hours gathering and processing 54 gigabytes of raw data, creating a mosaic that displayed the alignment of each segment. Following weeks of calibration, NASA announced the successful alignment of Webb's mirrors. This marked a critical milestone in the telescope's journey, represented by another unassuming star image with only a catalog number. This painstaking work has brought us one step closer to unprecedented discoveries that could forever change our understanding of the universe. Though 16 times brighter than the Sun, this star has no particularly distinctive features. Located 2,000 light-years away in our galaxy, it is just one of the 400 billion stars within the Milky Way. NASA's James Webb Space Telescope captured this star using a red filter to enhance its brightness. Unlike the deep cosmic visuals we often see from Hubble, this image focuses on clarity in the infrared spectrum, delivering the highest quality image ever taken in space. And what about the faint structures in the background? Those are distant stars and galaxies, adding a striking depth that makes this image iconic. Among these distant galaxies is one situated 5 billion light-years away, a remarkable feat considering Webb's mission is still in its initial testing phase. During its first trial, Webb focused on a star and detected an object 5 billion light-years away. NASA also released the telescope's first selfie, captured with the near-infrared camera, which showed the alignment of its 18 mirror segments. Over the coming months, these segments will be finely adjusted to work as a single, perfectly tuned mirror. Meanwhile, the James Webb Telescope was also photographed by the Gaia Space Telescope, both of which orbit around the Lagrange point, L2. On February 18th, Gaia captured Webb as a faint light spot from about 1 million kilometers away, visible thanks to Webb's reflective sunshield. These initial focused images are crucial, with breakthrough discoveries anticipated mid-year when the telescope operates at peak resolution and all scientific instruments collect data. So, what are NASA's goals for Webb's first year? James Webb's initial observations will include nearby dwarf galaxies, remnants of supernovae, and the universe's earliest stars. Serving as a kind of cosmic time machine, Webb will allow us to peer back 13.5 billion years, nearly reaching the origins of the universe, believed to have formed 13.8 billion years ago. The telescope may capture some of the most extraordinary cosmic events humanity has ever seen, such as the formation of the first galaxies and the universe's early structures. In one of its earliest historic captures, Webb imaged galaxy GN, Z13, the most distant and ancient galaxy observed so far, formed just 300 million years after the universe's inception. Since beginning its scientific mission in mid-July, Webb has already astonished scientists and space enthusiasts alike with its vivid imagery and groundbreaking discoveries. Prepare to explore how the telescope has detected exoplanets with possible life-supporting conditions, taken images covering an area equivalent to 1/5 of the Moon's diameter, and even revealed Jupiter's rings in unprecedented detail. The James Webb Space Telescope offers numerous advantages over the Hubble telescope. Positioned at about 1.5 million kilometers from Earth, 4 times farther than the Moon, it avoids the interference from Earth-orbiting satellites that can affect Hubble, which orbits only 547 kilometers above Earth. Unlike Hubble, which primarily captures visible and ultraviolet light, Webb is equipped with both near-infrared and mid-infrared cameras. Astrophysicist John Mather noted that Webb's sensitivity could detect something as small as a bumblebee at the distance between the Earth and Moon. Thanks to its infrared vision, Webb can peer to the universe's farthest reaches, where the oldest stars and galaxies reside. Hubble struggles to penetrate the dense clouds of gas and dust around many stars, planetary systems, and galaxies, but Webb's infrared capabilities allow it to see through these veils, akin to an X-ray. Webb's 6.5-meter diameter mirror, the largest ever sent into space, is nearly 3 times the size of Hubble's, capturing significantly more light. This powerful mirror allowed Webb to capture incredibly sharp, detailed images of the early universe in just a day, a task that would have taken Hubble weeks. In one of Webb's images, thousands of galaxies fill the frame, and at the center, a galaxy cluster, SMACS 0723, acts as a gravitational lens, bending light from more distant galaxies behind it, causing them to appear stretched and distorted. Some galaxies are so distant and faint that no telescope has ever imaged them before. Webb's first target in our solar system was Jupiter, observed during initial testing. These images revealed the gas giant's complex atmospheric bands and the iconic Great Red Spot in stunning clarity, exceeding astronomers' expectations. Following Jupiter, Webb turned to the exoplanet WASP, 96b, a gas giant discovered in 2013, located about 150 light-years away in the Phoenix constellation. Although less massive than Jupiter, it is 1.2 times larger in diameter and orbits extremely close to its yellow dwarf star, heating to over 1,000 degrees Celsius. Webb detected clouds, haze, and traces of water in its atmosphere, marking a breakthrough that Hubble had taken decades to confirm. Webb's swift detection of these molecules thrilled astronomers, as it sets the stage for future discoveries of life-supporting elements like water, oxygen, carbon dioxide, and methane on rocky planets. In another captivating image, Webb captured the Southern Ring Nebula, NGC 3132, about 2,000 light-years away in the Vela constellation. A gas cloud encircles a dying star, not formed by the central star, but by a second star nearby. Over thousands of years, this star emitted at least 8 layers of gas and dust, while the bright central star stirred these layers, forming intricate rings within the nebula, much like sunlight streaming through clouds. Hubble had previously imaged NGC 3132, showing its colorful and complex structure, but Webb's image reveals even finer details, capturing not only the nebula itself, but also distant galaxies in the background. In Webb's images, bright stars show 6 diffraction spikes due to its segmented 18-hexagon mirror design, while Hubble's images feature 4 spikes, caused by its single round lens with a secondary mirror mounted on 4 supports. Take a look at this breathtaking image, a vast swirling purple vortex. This is Webb's view of the spiral galaxy NGC 628, situated in the constellation Pisces, about 32 million light-years from Earth. Unlike Hubble's images, Webb's infrared capabilities provide a unique perspective, highlighting the dust and gas that obscure much of the starlight, while revealing supernova remnants and star-forming regions that infuse the galaxy with life. This image captures the dynamism of these regions as stars peek through the cosmic dust. Now, observe this larger image from Webb, spanning approximately 1 arcminute in diameter. It features Stephan's Quintet, a tight cluster of galaxies in the constellation Pegasus, about 290 million light-years away. 4 of the 5 galaxies appear to be locked in a gravitational dance, moving closer and occasionally merging, while the 5th galaxy lies some 40 million light-years away, observing the spectacle from a distance. The image is both awe-inspiring and visually striking. On July 12, 2022, Webb captured the nebula NGC 3324 in the constellation Carina, a stunning star-forming region that appears like a celestial landscape of mountains and valleys twinkling with stars. Webb's sharper images bring out even more details than Hubble's previous views. Nebulae, composed of interstellar gas and dust, come in 3 forms: emission nebulae, reflecting starlight; reflection nebulae, scattering light; and dark nebulae, like the famous Horsehead Nebula, which remain unilluminated. Formed from supernova explosions that scatter stellar remnants, these nebulae act as star nurseries, where gas and dust coalesce under gravity, forming a dense sphere that eventually ignites as a star. On September 12, 2022, Webb released an image of the Orion Nebula, 1,300 light-years away in the constellation Orion, and visible even to the naked eye. Webb's photograph reveals the Orion Bar, a massive wall of gas and dust. 2 of the brightest stars, members of the Trapezium cluster, formed here 300,000 years ago and emit intense ultraviolet light that sculpts and illuminates their surroundings. Another breathtaking image from Webb, shared by NASA on September 6, 2022, is the Tarantula Nebula, located 161,000 light-years away in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. As the largest and most active star-forming region in the local galaxy group, the Tarantula Nebula is home to exceptionally massive and hot stars, resembling ancient star-forming regions from the early universe. Webb's near-infrared camera revealed thousands of young stars previously obscured by dust, surpassing Hubble's abilities. At the center of the nebula lies a vast cavity encircled by radiant clusters of massive stars, casting a blue glow that accentuates the nebula's ethereal beauty. The Southern Ring Nebula, or NGC 3132, is a planetary nebula, so named because early astronomers mistakenly thought it resembled a planet. These nebulae are expansive clouds produced by giant stars nearing the end of their lives, shedding their outer layers as they become increasingly unstable. While planetary nebulae may seem rare, they're actually quite common. In our galaxy, which holds 200 to 400 billion stars, over 150 planetary nebulae have been documented. Situated about 2,500 light-years away in the constellation Vela, the Southern Ring Nebula has been observed in remarkable detail by the James Webb Telescope. Webb revealed that this nebula was formed by 2 stars in a binary system, rather than a single star. The brighter of the 2 stars influences the nebula's asymmetrical shape, while the central, aging star has already evolved into a white dwarf. The James Webb Space Telescope was designed to propel discoveries across various fields of astronomy, allowing scientists to delve deeper into the mysteries of star formation, galaxy evolution, and exoplanet characteristics. One of Webb's foremost missions is to capture light from the first galaxies that emerged after the Big Bang, providing insights into not only how galaxies form and evolve, but also into the broader story of the universe. Equipped to see in near and mid-infrared, Webb can peer into the early universe, observing ancient galaxies and cosmic structures that remain beyond Hubble's reach. Why the focus on the oldest galaxies? Observing them sheds light on the cosmic dawn, the epoch in the early universe when stars began to shine, illuminating the cosmos for the first time. It's like discovering a childhood photo of your great-grandmother. Thought to have begun 13.8 billion years ago with the Big Bang, the universe then entered a dark age, gradually cooling until matter clumped together under gravity. By studying these ancient galaxies, astronomers hope to answer foundational questions about our universe's origins. Already, Webb's images and data have challenged prior assumptions, reshaping our understanding of the earliest cosmic epochs. James Webb's data suggests that the universe's first galaxies appeared earlier than previously thought, and they seem more numerous and luminous than astronomers had anticipated. Surprisingly, these early galaxies display an orderliness and calmness that contrast with traditional models of chaotic early galaxy formation. Researchers theorize that dark matter halos likely provided a foundation for galaxy formation, attracting ordinary matter, like hydrogen gas, that condensed within them. Among these early galaxies, some are incredibly bright and ancient. For instance, the galaxy GSZ 130, one of the oldest known, formed around 320 million years post-Big Bang and is situated 13.6 billion light-years away. However, due to cosmic expansion, it is now around 33.6 billion light-years distant. These early galaxies were smaller than the Milky Way and produced stars at an astonishing rate, puzzling astronomers as to how they could form so many stars in such a short span. Some speculate they may contain an earlier, third-generation type of star that we have yet to observe or confirm. In a breathtaking November 2022 image, Webb captured the protostar L1527 in Taurus, with light shaped like celestial hourglasses. Dubbed the cosmic hourglass, this shape results from material propelled by the protostar, colliding with its surroundings and creating cavities. In the center, a horizontal accretion disk of gas and dust can be seen feeding material to the forming star. NASA suggests that this glimpse of L15527 offers clues about our Sun and Solar System's earliest stages. Though nuclear fusion has yet to commence in L15527, it will eventually accumulate mass, contracting and heating until fusion ignites and a new star is born. These snapshots offer just a preview of Webb's contributions, illustrating the depth and wonder of our cosmic origins. Many of Webb's findings validate long-standing theories, yet many questions about the universe's earliest stars and galaxies remain. The journey of discovery is only beginning, and we await the marvels that lie ahead. A little over 40 years ago, humanity sent 2 maps of Earth's location into space, which were attached to the exterior of 2 spacecraft. Now, both spacecraft are the farthest artificial objects from us. Today, the Voyager probes are located at the edge of the solar system, continuing their endless journey. If these probes ever encounter extraterrestrial intelligent civilizations and decipher the information on the plaques, it will not only reveal when the spacecraft left their home, but also point the way to our small and cozy world. It would be ideal if this civilization turns out to be peaceful and friendly. However, what if these sentient beings prove to be hostile? What if the potential Voyagers pose a threat to all life on Earth? Traditionally, people's opinions on this matter are divided into 2 camps. Some argue that it is extremely dangerous, and humanity should not have sent out such information, potentially exposing us to unknown risks. Others believe that the chances of encountering hostile beings are slim, and the scientific and cultural value of potential communication outweighs the risks. There is also a third category of people who do not share the opinions of either the first or the second group because they simply don't care. They are indifferent to the whole discussion. However, it's boring and uninteresting to talk about them, so let's focus on the first 2 opposing opinions and examine each of them in more detail. But before that, it would be good to understand what this map actually is, located on board Voyager. It's not the kind of map we are accustomed to, with north, south, west, and east as familiar markers. Instead, pulsars are used as markers. Pulsars are essentially rapidly rotating stellar remnants. They have existed for many millions of years, and each pulsar has its unique pulsation or flickering pattern, which can be used to calculate the position of objects in their vicinity. The famous astronomer Frank Drake, along with the equally famous scientist and writer Carl Sagan and the rest of the team, prepared golden records. These records were created by Drake and contained cosmic landmarks. These golden records, placed on Voyager's spacecraft, indicated the location of Earth in both spatial and temporal coordinates. But let's go back to pulsars. Why were they chosen, and why will extraterrestrial civilizations be able to decipher the coordinates of our world correctly because of them? Earthly time measurement would be meaningless because it is based on the rotation of our planet around the Sun. Another complication arose with the spatial coordinate system in space. No one will find us based on directions like up, down, east, or west. Even the stars change their astronomical timescale over time. An explanation like the second star to the right, then to the left, and straight until morning won't help those who may discover the probes, say, 1 billion years later. By the time the message reaches its recipient, such as the star Betelgeuse, which could serve as a coordinate point, it may no longer exist. That's why pulsars, discovered in 1967, were chosen. These super-dense dead stars act as excellent beacons in both spatial and temporal coordinate systems. They have very long life cycles that can last from tens of millions to possibly billions of years. Each pulsar is unique, and they rotate incredibly fast and emit pulses of electromagnetic radiation, which makes their behavior similar to that of a lighthouse. By calculating the delay between these pulses, astronomers can determine their rotation speed with incredible accuracy. Over time, the speed of pulsars slows down, sometimes by billionths of a second per year. By comparing the current rotation speed of a pulsar with the speed indicated on the discovered map, intelligent life could determine how much time has passed since the map was created. Drake hypothesized that if these beings can understand what pulsars are, they would definitely know their location in the galaxy. Using the obtained map, they could approximate the launch time of the spacecraft and trace its trajectory, ultimately leading them to the Sun. At that time, there wasn't much debate about the pros and cons of contact with extraterrestrial intelligence. Why? Because when Voyager 1, which is essentially Voyager 2, was launched, scientists had no idea if there were other planets beyond the solar system. It was all speculation. Therefore, no one really speculated about the possibility of intelligent life elsewhere. However, just over 10 years later, the Hubble Space Telescope appeared, and we now know that planets are quite common in our galaxy. The percentage of intelligent life on these worlds may be similar to our Earth. This revelation has sparked a strong desire to send targeted radio messages towards promising star systems. Among scientists, other prominent individuals, and especially our viewers, debates have intensified about whether our decision was wise and whether it would be better to simply continue listening to the cosmos rather than striving to be heard. However, for Voyager, it is already predetermined. They are there, they are flying, carrying a map of our home, and if someone is out there, they will definitely be able to find us. Therefore, we can only talk about the majors in hindsight. We cannot bring them back, and we cannot catch up to them. And why did we get fixated on Voyager? There are also Pioneer 10, Pioneer 11, and the New Horizons spacecraft, all carrying messages for extraterrestrial civilizations. If we rephrase the question and formulate it as whether it is worth sending signals with information about Earth into space, it raises more food for thought about the essence of it all. Let's ponder if it is dangerous or not. For example, the late Professor Stephen Hawking warned back in 2010 that humans should remain as quiet as possible because otherwise, advanced aliens interested in Earth's resources could take over the planet. He likened the situation to Columbus's landing in America, which did not turn out well for the Native Americans. To some extent, this is true. However, Dr. Douglas Vakoch from the SETI Institute in California has a different perspective, as this is precisely the institute dedicated to the search for extraterrestrial intelligence. Some believe that we should refrain from powerful transmissions, fearing an alien invasion. If these views spread, humanity would become isolated, avoid exploration, and minimize risks at all costs. Well, that's also true, isn't it? But can we not send signals directed at any stars or exoplanets? Not sending them into space is not possible because our planet has a constantly expanding, easily detectable radiosphere. It carries information about our civilization, such as the radio signals generated by television, cell phones, and satellites. Their presence can be easily detected from space, even though radio signals weaken the farther they are from their source. The entire question lies in their detection, which depends on the characteristics of the receiving equipment. Ordinary radio broadcasts can be detected if someone is actively searching for them, and hostile civilizations eager to attack someone will easily determine the location of Earth and the presence of life on it. Or, let's assume that extraterrestrial civilizations exist nearby. Let's take a look at ourselves from their perspective and try to answer the question, are we interesting to them? To answer the question of whether we are interesting to them, we occupy all our free time with blatant brawls. Historians once created a remarkable graph in a logarithmic scale, with time on the axes, starting from 6,000 years ago when the first writing appeared, and up to our time. They measured the duration of wars for each year, and it turned out that in the entire span of 6,000 years, there were only 3 months of peace when there was no war on the planet. A civilization engaged in self-destruction is not of interest to anyone, except perhaps to observe from a distance without making contact, just as we do when we observe fighting beetles in a jar. Or let's say that for an extraterrestrial civilization, their intentions are indeed aggressive, confirming the fears of Stephen Hawking and others. Why would they come here to engage in warfare and expend energy and resources? What valuable resources does Earth possess? It is unlikely that they would come here for oil, water, or anything else. Perhaps we humans ourselves are the valuable resource. But enslaving us for hard labor doesn't make sense. It's not beneficial at all. Humans are susceptible to illness, fatigue, and need food and drink. Moreover, they are fragile and cannot work for extended periods. If a civilization is truly intelligent, it would be easier for them to build an army of robots to handle laborious tasks. But in reality, if there were many such civilizations, whether good or evil, it wouldn't matter. This means that they haven't developed such ships and won't come, and we will never travel anywhere. It's all due to the tremendously vast scales of space. For example, we received a signal from a civilization living at the center of our galaxy. The signal from their council takes 30,000 years to reach us. We urgently send them a response, requesting knowledge about the universe, equations of quantum gravity to be placed in their library, and everything else. But even if they receive the signal, it will take another 30,000 years for their response to reach us. So for those who receive it, it becomes pointless. And if we consider intergalactic distances, the Andromeda Galaxy, the closest one, is 2 million light years away. This means we will receive that knowledge in 4 million years. Let's assume that in a galaxy with 100 million stars, there are millions of civilizations similar to ours. But some of them emerged 100 million years before us, while others will emerge 100 million years later. What would we even talk about with civilizations that are 100 million years older than us? We would be like insects or microbes to them. Let's say we send them a signal, they receive it, and from their perspective, they see it as something trivial. In conclusion, the likelihood of the maps on board the Voyagers reaching the shores of extraterrestrial civilizations is extremely low. The spacecraft are not aimed at any specific star. They are simply flying. If extraterrestrial civilizations have powerful enough radars, they might be able to detect Voyager from afar. But in that case, they would have already detected signals from our planet, according to our channel's opinion. The Voyager spacecraft, just like the Pioneers and New Horizons, pose no danger to Earth. Instead, they are a reason for pride. Imagine that those images, sounds, and maps of planet Earth can endlessly and imperceptibly float through space. Moreover, they will likely outlast us. Humanity might not exist, but at some beautiful moment, these artifacts made by human hands could be the last remnants in the universe. In our Milky Way galaxy alone, there are at least 300 million habitable planets. It can be assumed that over time, another civilization would be capable of achieving the technologies necessary for interstellar travel. Yet, humanity has never encountered extraterrestrial beings. These three unexplained facts are unified by the Fermi paradox. So, what can be inferred from this? Either they cannot or do not want to contact us. And what about ourselves? Throughout the time that scientists have been searching for extraterrestrial life, they have been envisioning it as a likeness of ourselves. One more important note. Until we delve deeper into the topic, let's not get too distracted by science fiction. At the same time, the problem of defining the conditions necessary for the emergence of life is being discussed and studied. This question is highly complex, as the answer is intertwined with terminology and the peculiarities of a scientific disciplinary approach. Renowned astronomer and historian of science, Stephen J. Dick, traced the history of debates on the definition of life throughout the 20th century in his book Life on Other Worlds. Among other things, he discusses an article by the evolutionary biologist George Gaylord Simpson when U.S. scientists began preparing for the search for life on Mars. Simpson argues that life forms in different conditions do not necessarily resemble familiar earthly forms. The primary definition of life, with which most biologists would agree, is that living organisms are characterized by the ability to grow and reproduce independently. However, even the applicability of this definition remains unclear for crystals, not to mention the extensive gray areas within biology itself. For example, it is unclear whether viruses, which have their own genome but are not capable of reproducing themselves independently, should be considered alive. It also seems that the aforementioned definition does not include so-called prions, which are single proteins capable of replication. It can also be noted that there is agreement among scientists that bacteria represent the most rudimentary form of life. Thus, the subject of debate extends not only to the definition of life, but also to the criteria for its emergence. Carbon is key. There is a persistent assumption that if extraterrestrial life exists, it should be similar to life on Earth. Specifically, the molecules responsible for life's chemical processes should primarily be composed of carbon. It is understandable that such a form of life is most familiar to us, making it extremely difficult for humans to imagine alternative biochemistry. Scientists speculate that we will be able to discover a habitable planet within 10 years. There is a high probability that it will orbit a red dwarf star. After all, these stars, which make up 80% of all stars, are most prevalent at relatively short distances from Earth. And most importantly, there could be life similar to ours there. So, there is a planet similar to Earth orbiting a red dwarf. In order for liquid water, a vital attribute of carbon-based life, to form on its surface, it must orbit close enough to its star. However, much closer than our planet does. After all, as we know, red dwarfs are much colder than the Sun. Therefore, under the influence of gravity, such a planet would not rotate around its axis and would always be facing one side towards its star. There would be no change of day and night or seasons. The second hypothetical object with life is the blue moon. It is a fictional moon of a Jupiter-like planet, almost entirely covered in water and having a very dense atmosphere. These conditions allow scientists to speculate about the existence of flying creatures the size of whales on the moon. The blue moon should be comparable in size to Earth, but according to the model, the atmospheric pressure on its surface is 3 times higher than on Earth. A characteristic feature of the moon is the absence of polar ice caps. The dense atmosphere and the ocean covering its surface reduce temperature fluctuations. The excess oxygen in the atmosphere theoretically should lead to increased muscle strength in celestial whales, whose wingspan reaches 10 meters. Billions of algae and moss float in this air, which serve as food for the celestial whales. It's a beautiful picture, of course. Silicon structure. But if we completely depart from the idea of carbon, what remains then? It turns out that scientists have delved into the concept of extraterrestrial life based not on carbon but on silicon. Science fiction authors have also been fond of this idea. It is strange, however, that literary silicon aliens, for unknown reasons, always resemble clay statues or animated crystals, even though from a scientific perspective, the external differences between silicon-based and protein-based beings could be minimal. After all, silicon is simply meant to replace carbon in organic molecules. And the substance that forms the flesh of silicoids, silicone, is widely used today to imitate certain human body tissues. Theoretically, the scorching worlds dissected by rivers of lava flowing at the base of black basalt rocks could be a natural home for silicoids. However, even on such planets, silicon-based life would not create a great civilization because hydrogen sulfide is rare, and a transition to synthesis based on water would be impossible. Water cannot coexist with magma. Other liquids. Interesting possibilities arise from replacing carbon with a combination of nitrogen and phosphorus. In this case, for plants to undergo photosynthesis, they would require ammonia and phosphine, a compound of phosphorus and hydrogen, instead of water and carbon dioxide. Life based on a phosphorus-nitrogen foundation could thrive in cold worlds similar to those described in Paul Anderson's novel 3 Worlds to Conquer and Kir Bulachev's story Snow Maiden. After all, ammonia freezes only at a temperature of -78 degrees Celsius. From a metabolic standpoint, nitrogenoids would be upside-down creatures. Terrestrial plants synthesize fuel, hydrocarbons, while producing oxygen as an oxidizer. However, in icy synthesis, hydrogen becomes redundant. By inhaling this highly efficient fuel, nitrogen beasts would need to extract oxidizer from plant-based food, returning nitrogen and phosphorus to the plants. The organic substances based on nitrogen and phosphorus, though, are not sufficiently stable, but only under terrestrial conditions. The reliability of chemical bonds increases as the temperature drops. Therefore, the nutrient broth necessary for the emergence of nitrogen-based life could accumulate in ammonia seas. However, the most suitable life form for realistic conditions is the alternative life in which oxygen is replaced by sulfur. It may seem like a minor detail, but in such a case, synthesis becomes possible only by replacing water, which turns into a lethal poison, with sulfuric acid. This means that suitable conditions for hypothetical sulfocarbon bacteria can be found on the neighboring planet, Venus. The clouds on waterless Venus consist of sulfuric acid. Another thought that arises is that during anoxic photosynthesis, sulfocarbon bacteria would release hydrogen sulfide instead of water vapor. However, hydrogen sulfide is an unstable compound that quickly breaks down due to cosmic radiation. Yet, hydrogen sulfide is present in the atmosphere of Venus for some reason. Its reserves cannot be replenished through volcanic eruptions because the planet's interior has cooled down and volcanic activity has long ceased due to the lack of a massive satellite. Could non-living creatures produce this gas? However, of course, hydrogen sulfide in the Venusian clouds may have a different, less exotic origin. Bacteria. In general, Venus is a rather interesting planet. British scientists believe that the space at an altitude of 51 to 65 kilometers above the surface of Venus could be inhabitable. They have determined that the temperature there ranges from -20 to +65 degrees Celsius. The atmosphere is composed of water vapor heavily saturated with aerosols of sulfuric acid. It is under such conditions that extremophilic bacteria, which feed on sulfur, can survive. For example, the Archaeon pacrophilus, which inhabits hot brine pools on Hokkaido Island. On Earth, extremophiles occupy the most lifeless places, such as hot underground springs, anaerobic reservoirs, and permafrost. Some microbes have adapted to feed on inorganic substances, assimilating them with the help of solar energy. Venus lacks a strong magnetic field to protect it from the flux of high-energy galactic radiation. Solar flares there are more dangerous than on Earth, which has a more distant orbit. However, the atmosphere of the planet of crimson clouds is many times denser than Earth's and provides better radiation shielding. Scientists believe that there is still no chance of survival on the surface of Venus. Liquid oceans and a biosphere may have existed on early Venus, but subsequent greenhouse effects transformed it into a dry, sterile desert. It is unlikely that life has survived beneath the planet's surface or in the soil. The only place where it could potentially thrive is among the clouds high in the atmosphere. For example, bacteria like Mesophilic Deinococcus radiodurans can survive even when exposed to 10 kilograms of radiation. Hyperthermophilic archaea, like Thermococcus gamma tolerans, can reproduce at 88 degrees Celsius and withstand a radiation dose of 3 kilograys. So there is something to ponder upon, an alternative reality. Consider completely different realities, for instance, as mentioned by science fiction classics such as Stanislaw Lem in the story The Truth. These works mention beings composed of magnetic fields and molten plasma. In Lem's novel, The Invincible, humans encounter a planet inhabited by feral and degenerated machines. Lem also describes Solaris, a sentient ocean that neither emits nor consumes anything as far as one can discern, except, of course, for curious researchers. In Fred Hoyle's novel, The Black Cloud, signs of life emerge from a drifting gas cloud in space. The common characteristic of all these non-chemical creatures is their mysterious and likely artificial origin. Intelligent beings do not arise by chance. Complexity must arise from simplicity, and the only known path to complexity from simplicity is evolution. However, it is unclear what would serve as the carrier of heredity within a plasma clot and how a gas cloud or an ocean could undergo mutations and natural selection. Alternatively, consider the dark idea expressed in horror games such as Quake, Dead Space, or Doom, where extraterrestrial life forms are unpleasant for humans. The human brain has numerous limitations. We are misled by cognitive biases, optical illusions, and blindness to things we are not ready to see. One question that has always haunted the study of extraterrestrial life is whether we can recognize life that is so different from what we encounter here on Earth. Scientists have long urged us to expect the unexpected. Life on other planets may not leave the same biological traces as earthly organisms, making their detection challenging from our perspective. And if this life has also transcended the bounds of the material world, it becomes an incomprehensible phenomenon for us. Today, the search for potentially habitable exoplanets continues, and some fairly effective methods for their detection have already been developed. The big question is how many more Earth-like planets exist that can be discovered. After that, the question arises about their habitability and what form life could take on these planets. The laws of physics are universal. The 12 fundamental quantum particles, with their unique fields, and the 4 types of fundamental interactions form the basis of matter. It is these elements that make our world the way it is, and no different. Regardless of what we discuss, whether it's our planet or the most remote corners of the universe, the same laws apply everywhere. All the observations and experiments conducted by humans over the past few centuries, whether with a telescope or a microscope, only confirm this thesis. Perhaps the hyper-intelligent extraterrestrial life of an alien being will seem unfathomable and complex to us, as in Stanislaw Lem's novel Solaris. But one thing is clear. We still have a long way to go to establish the first productive contact, or perhaps simply dispel all our dreams about it. On Saturn's moon Titan, there are both land and seas, as well as 6 elements that are abundant, so scientists believe that there is a high possibility of life on Titan. Let's take a closer look at the possibility of life on Titan. Titan, a moon of Saturn, is huge, second only to Ganymede in size among moons in the solar system. With a radius of about 2,575 kilometers, it is 1.5 times larger than the moon and about 40% the size of the Earth. Although it can be observed from Earth, it is difficult to observe Titan's interior properly because of its thick atmosphere. Therefore, Titan was a mysterious celestial body shrouded in mystery for a while. However, in 1997, the European Space Agency and NASA launched the Cassini spacecraft to explore Saturn and its moons, and this spacecraft visited Titan. Hundreds of photos and atmospheric composition analysis were sent to Earth, revealing its identity. The image of Titan sent by the Cassini spacecraft was quite ordinary, with mostly wide plains and sand dunes created by the wind in low-lying areas. There were even mountains as high as 3,330 meters. At first glance, these photos looked like hazy days on Earth with dust or fine dust. Clouds were also observed in the sky of Titan. Weather phenomena occurred on Titan similar to those on Earth, with rain falling and lakes forming on the plains, and even seas forming in low-lying areas. Like Earth, liquid circulation also occurs on Titan. With this information, it seems that the speculations of Professor Carl Sagan, who was always right about the possibility of life on Titan, were not true. Or perhaps humans on Earth will one day be able to live on Titan. Because it is located as far as 1.4 billion kilometers away from the Sun, it doesn't receive enough solar heat properly. So as it turns out, the average temperature of Titan is minus 179 degrees Celsius. Titan can be called a supergiant freezer. Normally, if the temperature is minus 179 degrees, all the clothes on this satellite should freeze. Clouds 3 and oceans confirmed through Cassini-5 have a significant discrepancy with what we usually know. The hills on Titan were formed by completely freezing, and the seas on Titan were made up of methane. Also, the clouds were not white clouds gathered by water vapor like Earth, but had a murky appearance. When we only saw Titan in photos, we thought it could be habitable, but it's definitely not a place with a climate like Earth. Even though our environment is like this, scientists' opinions were very positive when Titan was discovered, except for Earth, as it is the only place where liquid is maintained on the surface in a stable way. This is the first celestial body that we confirmed, and there might be life forms here. Also, thanks to the layered structure of Titan, there are winds and rain, making it an optimal place for life. Now let's take a closer look at Titan. Titan has a dense, murky atmosphere. The atmospheric pressure is about 1.45 times that of Earth, and about 98% of the atmosphere is made up of nitrogen with trace amounts of methane. Interestingly, aside from Earth, Titan is the only celestial body in the solar system with nitrogen. Scientists say that Titan's nitrogen-rich atmosphere is very similar to the primitive atmosphere of Earth about 3.8 billion years ago. If we can analyze Titan's atmosphere, we can learn more about the changes in Earth's atmosphere. Currently, nitrogen is the most abundant gas in Earth's atmosphere, accounting for 78%, followed by oxygen at 21% and argon at 0.90%. These atmospheric compositions are present on Earth. However, these ratios have changed slightly over the course of several hundred million to billions of years. Titan's dense nitrogen atmosphere causes a greenhouse effect, which maintains a high temperature despite receiving very little solar radiation. This keeps methane in a liquid and gaseous state. If Titan did not have nitrogen, all of its methane would have frozen, and Titan itself would have become a completely frozen celestial body. Amazingly, the study of Titan has even led to the discovery of some unique molecules that are essential for life formation, such as cyclopropenylidene, which is composed of carbon and 2 hydrogen atoms. This molecule is an important building block for life and also serves as food for other organisms. Although cyclopropenylidene is difficult to pronounce and understand, it is a crucial substance that cannot be overlooked in the formation of life in the universe, and has been observed occasionally in interstellar matter. However, except for Titan, there has been no discovery of such compounds in other celestial bodies, so it's really amazing and remarkable. Cyclopropenylidene, composed of 2 carbon atoms and 2 hydrogen atoms, has been discovered in Titan's atmosphere using the ALMA radio telescope by NASA's research team. The discovery of this molecule, which is difficult to pronounce and has caused quite a stir, is an essential component of the formation of living organisms and can also serve as food for other organisms. Although it has occasionally been observed among interstellar substances in the universe, it has never been found in any other celestial body until now, except for Titan. This is really remarkable, especially considering that it has only been found in 2 places, Titan, which is similar to the primitive Earth environment, and some other celestial body. Moreover, many benzene compounds have also been detected. These compounds play a role in the formation of complex organic matter. In addition, there are other compounds such as argon and carbon monoxide in the atmosphere of Titan, which is conducive to the formation of organic matter during its evolution. It is an environment where organic matter formed during its evolution is falling like light snow. There is one more fact to note about Titan. It is that 82% of its surface is covered with organic matter. According to Dr. Rosalie Lopez, a NASA scientist, more than 82% of Titan's surface is composed of organic matter that has fallen from its atmosphere and has been transported by winds. This means that Titan's organic matter is very abundant, which suggests the possibility of the existence of living organisms. This is an exciting discovery that raises the possibility of the existence of microbial or other life forms. If such life forms were present, there would be abundant sources of food. Another important fact is that there are oceans on Titan. Prior to this, lakes were discovered on Titan, but now it has been revealed that there are oceans as well. If the liquid in these oceans seeps into the subsurface, it could provide sufficient conditions for the birth of life. While this liquid is not water, Titan is the only celestial body in our solar system, besides Earth, where liquid exists on the surface. Scientists have found that Titan's oceans are deeper than previously thought. In fact, during an investigation of one of Titan's seas, Kraken Mare, the equipment that was used to probe the sea was limited by its technological capabilities and was unable to reach the bottom, which is at least 300 meters deep. This is more than 7 times deeper than the average depth of the West Sea, which is approximately 43 meters. In addition, there are geological activities like volcanic activities in Titan, and if such visual activities occur, an ecosystem ranging from microorganisms that use organic matter around the hot springs as food to predators on top of them may have formed. From the beginning, including Titan, organic matter is very abundant, so if miraculously some organisms were discovered on Titan, an ecosystem of organisms and their mothers could have already formed in Titan's seas. The most important clue is this. Recently, it was found that after hydrogen descends from Titan's atmosphere, it disappears from the surface, according to the data collected by Cassini. Some scientists at JPL are claiming that this may be the result of primitive life breathing in and consuming material on the surface. However, Titan's flowing liquid is methane, so if life is actually emerging and surviving here on Titan, the living organisms of Titan may be based on methane. Scientists are looking at Titan's existence of life with a very positive outlook. NASA has started the Dragonfly project to explore the seas of Titan. They will fly a kind of drone powered by a blue-tone fuel to observe various terrains of Titan. The Dragonfly project is expected to launch in 2026 and arrive near Saturn in 2034. They plan to use a parachute to land on Titan when the weather is favorable, and then switch to flight mode to explore and collect samples. Previously, Genius explorations were mostly conducted using ground vehicles, but this method had limitations in mobility, so the goal is to easily explore multiple locations. I will go crazy with my child's drone to explore. The target distance and time for the exploration are about 2 years, 7 months, and approximately 175 kilometers. This distance is twice the distance traveled by all Mars rovers so far. NASA hasn't made a final decision yet, but they say they could send a 1-ton submarine to Titan. The purpose would be to explore the largest Kraken Mare Sea on Titan, which has a fairly deep depth from the beginning. A submarine would be 10 times better than a drone to explore it. If we explore the liquid methane ocean with a submarine, we could thoroughly examine the ocean floor. What do you think about the possibility of life on Titan, Saturn's moon?